guys. Okay, equivalent resistance for a battery, parallel circuit with 3 resistors, 2, 5, and 10. Prove Kirchhoff's current law, showing the current nodes equal the current out. Okay, so here's my resistor circuit. First one, second one, third one. Okay, 5 volts, 2 ohms, 5 ohms, 10 ohms. So for parallel circuits, they add the inverses. You add all the opposites together. Okay? Instead of adding just the straight numbers, you add the inverses. So to get the equivalent resistance for the parallel, you would say 1 over Req equals 1 over 2 plus 1 over 5 plus 1 over 10. Get a common denominator. Okay, I am going to go kind of fast through this. Just brace yourself. If you're having trouble with common denominators, you can always turn it into decimals. But I think that's a little harder. Common denominator is 10. So in order to get 10 on the bottom, I'd have to multiply the top and bottom by 5. That gives me 5 out of 10. In order to get 10 here, I'd have to multiply the top and bottom by 2. That gives me 2 over 10. And then 1 over 10. Add those up, and you get 8 out of 10. But that's equal to 1 over Req. I don't want 1 over R. I want just R. So I flip the top and the bottom. And I get Req equals 10 over 8. Simplifies to 5 over 4. Or you can write it as 1.25. Okay, obviously a little trickier than just add all these numbers up. So, I mean, not that this has anything to do with anything, but there might be a better chance I would have you do the thing that requires more thought than the one that's just adding numbers. I don't know, just random thought out there. Just throwing that. There's probably nothing, but just a thought I had. So so that gives me the Req. To find the IEQ, V equals IR. So the V is 5. IR is what I just got. When you have a fraction, the way you get it to the other side is you multiply by the inverse. So multiply both sides by the opposite. So these cancel. 5 goes away. You get IEQ equals 4. Okay? So I've got that. I've got the R. I've got the I. Now I'm ready for the last thing, which it says prove Kirchhoff's current law. So Kirchhoff's current law is this one. Current in equals the current out. Okay. For this one. See if that's enough space. Hopefully it is. So the current in equals the current out. So the current in is the current coming from the battery, right? That comes into each of these loops. Okay, it's the current in. So the current in is 4 amps. That equals the current through 2 plus the current through 5 plus the current through 10. Right? The current has to split between those 3 branches. So I have to add all those up, and that equals the 4. Okay? How do I find those currents? V equals IR. Everything in parallel has the same voltage. Everything in current has the same, everything in series has the same current. Everything in parallel has the same voltage. So, V equals IR. Divide by 2, you get I2 to be 2.5. Okay, V equals IR. Last one, V equals IR. 2.5 plus 1 plus 1/2 is 4. That's what I said it should get. Again, you're likely to get this as several problems. One problem where you're having to find the equivalent resistance for a parallel circuit. One where you just have to do a basic V equals IR. And then something like this where I give you some of the voltages or the currents and you got to find the other. Or you have the total and you got to find what the split would be. Something like that. And that's kind of the idea. Okay? So 2 different problems, but similar processes. Questions on that one? Killing it.